This will be problem 16 through 30. The first lesson here starts off with, as you can see, using exponents, roots, and absolute values perhaps to solve problems. So we're going to be simplifying in a whole bunch of different ways here. So let's take a look at what we have here. Number 16 looks like it's got some absolute value. That's what these symbols refer to. And then it tells you to substitute for n the number -11. So let's do that first. Let's put in -11 for n and see what we have. Alright, see, absolute values work a little bit like parentheses in the sense that you should work inside them first. But absolute values have one major difference, which we'll get to in a second. So if we just do inside the absolute value symbols, -11 plus 5 is going to be -6 with an absolute value. Now this is like saying -2 times whatever the absolute value of -6 is. Absolute value refers to the distance from 0 on a number line, but a simpler way to think of it is it turns everything inside it positive. But you should always simplify first before you get to that part. So now that we can't do anything else inside the absolute values, here we should simplify. So it would be -2, and absolute value of -6 is just 6. So what we're really doing is saying -2 times +6. So the absolute value symbols turn into just a +6. And since we did the absolute value of -6, the symbols go away and we're left with just a 6. So our final answer is really -2 times 6, which is -12. So our answer is D. Okay, number 17 looks like it combines the same kind of thing, absolute values and so on, but we also have a lot of order of operations and so on in this problem. So I'm going to rewrite this problem over here just to make it easier to see. So we have 2 and then in parentheses 13 minus, and then we start absolute value symbol, -11 plus 2, absolute value, close the parenthesis, minus absolute value again, 10 minus 7, close the parentheses, close the absolute value, and square it. So wow, I guess this is just a test of how well you know absolute values and how well you know order of operations. Okay, so let's start inside this set of parentheses and then inside the set of absolute values. I'm going to start writing some of this over again. Okay. So 2 parentheses 13 and minus, that's exactly a recopy of this part. Let's look at this part here, absolute value of -11 plus 2. Okay, absolute value of -11 plus 2. Let's write absolute value again, but then it'll be -11 plus 2, which is -9. Like that. And then we can work out this one too. This is minus and then absolute value of 3 squared. Okay, so let's keep simplifying. So 13 minus, okay, the absolute value of -9 is +9. So this is 13 minus +9. And then here, the absolute value of 3 is just 3. So it would be 3 squared. Okay, so then we have 2 times 13 minus 9, which is 4, minus, okay, 3 squared. Remember, you wouldn't take the minus sign with the 3, right? It wasn't in parentheses, so it's just 3 squared. So we have a minus, and then 3 squared is 9. So finally what I have is 8 minus 9, which is -1. So that is just a pure test of order of operations and of absolute values. I'm sorry, I didn't realize that was so cut off. Let me slide it over for you so you can see what I was doing. We had the right side of this cut off there. 10 minus 7 in absolute value is 3 inside the absolute value, and the absolute value of 3 is still 3. So finally, when we take 3 squared, it's 9. And notice the minus sign doesn't apply until the very end, right? Because all of those things come in the order of operations first. Okay, let's look at number 18. They're trying to make them as hard as possible, I suppose. 7 square root of 12 plus 6 square root of 108 all over the square root of 2. Okay, one of the things that comes to mind is you're not supposed to have a square root of 2 or any square root in the denominator. So we might have to take care of that unless we can get it to cancel. We'll look at that in a minute. How about this? If you look at it like this, let's separate it into two problems. Well, we can get rid of the square root of 2 on the bottom by doing this. This is like basically under 1 square root. You can divide this. So square root of 12 divided by square root of 2, that's going to be 7 square root of 6. Plus, over here we can do the same thing, 6 square root of 54. So that actually gets rid of the square roots on the bottom right away. That's good news, because if you look at our answers, none of them have a square root in a denominator. So the only question now is, how can we split this up? Because we can't add them as they are. They'd have to both be the same square root. Well, there's not too many perfect squares, actually there are none, that go into the square root of 6. So that one's pretty much as simplified as it's going to get. So we might have to look at this one and say, is there a perfect square that divides evenly into 54? I think you would look at it and say, I'm going to bring this one down, 6 times the square root of 9 times the square root of 6. 9 times 6 is 54, and 9 is the perfect square. So it's, I'm going to come over here, sorry. 7 square root of 6 plus, okay, 6 times 3 square root of 6, because the square root of 9 is equal to 3. So what I really have is 7 square root of 6 plus 18 square root of 6. If I combine them together, I get 25 square root of 6. My answer is B. Alright, these problems all involve estimation, which for some reason is a big thing on the Keystone test. Estimation is kind of like a real quick, can you do it in your head type of problem. So it says George's car can travel 28 miles per gallon of gas. If the car has used 10 gallons, approximately how far has he driven? Okay, well, this is about as simple as it gets, right? 28 miles per gallon, and he uses 10 gallons, so 28 times 10, 280. Number 20 says it costs the shoe company $20.67 to produce one pair of running shoes. The company sells each pair of shoes for $75.07 in stores. If the company sells 145 pairs of running shoes in the month of March, what is the company's approximate profit from running shoes in March? Okay, so they want you to estimate here. So I don't think you're going to use $20.67. I think you're going to say $21. And I also don't think you're going to use $75.07. I think you're going to say $75. You might even have to estimate this, but let's hold off on that for a second, because it might be something like simple like 150, but we'll find out. Okay, so it wants to know, what is the profit? Okay, profit is basically revenue, or money you sold it for, minus the cost. So in this case, it's $75 minus $21, or the profit per pair is equal to $54. So that means that if they sold 145 pairs and each one of them profits $54, then basically what we would do is take 145 times the $54, and that should give us our total for the month. This is probably a calculator problem. We can go ahead and do that. So I'm going to get out my calculator here very quickly. So 145 times 54, and I get $7,830. This looks to be answer A. So if you think about it, that's an estimation because we estimated high on the cost and actually a little low on the revenue. So we probably actually make more money than that. But in terms of estimating it, it's not a bad idea to estimate a little bit high on the cost of the product and estimate a little bit low on the revenue, because what that means is you'll be estimating low on your profit. So when the numbers would actually come in, you would actually make more than your estimation, which is always a good thing. Alright, number 21 says a fast food restaurant sells between 164 and 328 hamburgers per day. If the company profits $82 per 82 hamburgers sold, approximately how much does the company profit in 1 year from hamburgers? Wow, that's a lot. Okay, so I look at it like this. I see profit of $82 per 82 hamburgers. To me, that means $1 per hamburger. And I also see 164 to 328 per day. Okay, so then let's look at the low number and we'll look at the high number. So if we say 164 times 365, right, this will be the low. $59,860, and the high would be 328 times 365. That would be 119,720. So our estimate of profit should be somewhere between these two, right? So obviously C is no good, right? We're not talking profits in the millions here. D would be lower than the lowest one, and B would be higher than the highest one. So you can see that A is the correct choice here because it's the one that falls in between our two potential estimates. Alright, so we move into the next part of this thing, which is on simplifying polynomials. It looks like the beginnings of these are just adding and subtracting. When we did this in class, we talked about adding polynomials is essentially combining like terms. Right? These are combining like terms. All of these are combining like terms. So since there's a plus sign here, we can just lose the parentheses automatically and start combining them together. So 8x squared and 3x squared is 11x squared. Negative 4x and negative 7x makes negative 11x. And negative 8 and negative 3 makes negative 11. So we're looking for 11, negative 11, negative 11. It is A. So we go to 23 and it's the same concept. Combine the like terms because there's just a plus sign here. So 6x to the third and 4x to the third is 10x to the third. Okay, I have no other x squared, so it's plus 3x squared. I have no other x's, so it's minus 4x. And then negative 5 and negative 3 is negative 8. Looks like the answer is A again. So then we look at number 24, which has a minus sign in the middle of them. The only difference between number 23 and number 24 is that with a minus sign, you would actually rewrite all of the first terms in the first set of parentheses. But the minus sign means that you should distribute this negative, so to speak, to everything in here, or change the sign of everything in the right set of parentheses. So it's actually going to be negative 3x squared, negative 2x, and negative 6. Like this. And then otherwise you can combine like terms. So it's 9x and negative 3x squared. That's going to be 6x squared. 6x and negative 2x is positive 4x. And 4 and negative 6 is negative 2. So we're looking for 6x squared plus 4x minus 2. And it turns out that that answer is A once again. Keep going. So lots of polynomial simplifying here. So we did quite a bit of that in class. So now we're on to factoring. Okay, when I see two terms factoring, I think difference of two squares, which means that if I start with x to the fourth minus 1, I'm going to split that into two simple square roots. Square root of the first term and the square root of the second one. The square root of a 1 is still 1. And I can put a minus sign in one and a plus sign in the other. It always works like that. But see, again, I'm always looking to take it all the way down, and if I look at my answers over here, it looks like answer A is good, except it says factor the expression completely, which means that if you can take it farther than it is, you need to do that. See, this is where this becomes a little bit tricky, because it looks like if you do this part, you get answer A. And answer A is correct, but it's not complete. It does eliminate C and D though, but maybe, anyway, at least C. Let's take a look at this. See how you have another difference of two squares right here because there's a minus sign? It's a difference of two squares because I can do a square root of that first part again. Square root of x squared is x, and the square root of 1 is 1 again. So I'll have another minus and another plus like that. But see, this one with the x squared, I can't do anything else with this because it's not a difference of two squares. Difference means subtraction, and that's an addition sign. So this one can't go any further, but this one could have. So this is your final response right here. X minus 1, x plus 1, and x squared plus 1. So it's actually B. So B is the absolute complete factoring, whereas A, although correct, is not totally finished. So looking at number 26, I would say the same kind of thing, except my first thought is can I always look for a greatest common factor here? And it looks to me like there's a 4 present in both of these things. So I would first factor the 4 out, and it would leave me with x squared minus 1. And then, with the 4 on the outside, I would say this is again another difference of two squares. So x minus 1 and x plus 1. Right, we square root the x squared to get x and x, and square root the 1 to get 1 and 1 again. With a minus and a plus, this is as far as it goes. So it looks like, well, I wrote the minus first and the plus second, but B is the same answer, so it's B. Okay, number 27 is what I would call general factoring. So we're looking for, because it's 3 terms, and it's just a plain x squared there, we can write x and x. So the only question is what two numbers multiply to give you 25 and also add to give you negative 10? Well, you have to play around with it a little bit, but I think you'd find out that it would be negative 5 and negative 5. Think about it. Negative 5 times negative 5 is positive 25, and if you add negative 5 and negative 5, you get negative 10. So this is the correct factoring, but if you look, this is not the answer over here. It's because they wrote the answer a little bit differently. When you have the same thing times itself, another way to write that is to take that same expression and call it squared. So this is D. Alright, so we move down to 28, 29, and 30, which are clearly the more difficult problems on here. So we'll take a look at it and see what we can do. Alright, I look at number 28 and say, well, okay, it's basically two problems, one on the top and one on the bottom. So let's focus on the top part first, and we'll leave the bottom alone for now. So the first thing I'm going to look at is I could take a 3 out of each one of these terms, and actually I can take an x out of each one. So I'm going to divide a 3x out of it, greatest common factor. It would leave me with x squared plus 6x and minus 5. Okay, so what that does right away is allow me to cancel the 3 x's. So what I'm really left with is x squared plus 6x minus 5. And I would say, can I factor that at all? Well, I'd be looking for two terms that multiply to give me negative 5 and also add to give me 6. Well, if you try to factor that, I mean, it would be x and x, you would think. But I think what you're going to run into is there are no numbers that multiply to equal -5 and also add to equal +6. So at this point, it's probably not factorable this way. And if you look over here, none of these final answers are factored answers anyway. All they are is a reduced polynomial. So this answer is C, because that's where we're at right now. So sometimes you actually can't factor it. I think that problem was a lesson in can you recognize there's a greatest common factor in the top part. Okay, number 29. Again, here we are with what looks to be a very complex factoring problem. But we'll find out if it's a little bit easier than it looks. Okay, the bottom one, it's two terms, and it's not a difference of two squares because it's not a minus sign. So I'm thinking that's probably not factorable. But let's look at that top part for a second. The top part is a difference of two squares, right? Because you can divide this by 2, and this is an easy square root, and it's a minus sign. So let's split it up into two things. If we square root the variable part, we're going to get x to the 7th twice, and then we square root the 16, it would be 4 and 4, and one of them would have a minus and one would have a plus, according to the rules of difference of two squares. So maybe now we can see where this is going. The x to the 7 plus 4 here and here would cancel, and the only thing left would be x to the 7th minus 4 on the top. Our answer to this is C. So again, it looks tough until you realize that almost guaranteed something is going to cancel out, which is the whole point of factoring. It's called dividing a polynomial, but you're using factors to do it. Alright, let's take a look at the last one. So again, we have what looks to be a pretty complex problem, and we'll see if maybe there's some way to factor it out. Okay, so I'm going to leave that top alone for a minute and look at the bottom, see what we can do with that. So go to the next step. And I'm thinking that we should be able to factor it like normal. So we need two numbers that multiply to get -42 and add to get -1. So 6 times 7 is 42. If the 7 is negative and the 6 is positive, we would have -7 times 6 is -42, and -7 plus 6 is -1. So this is factored correctly. So now normally they're supposed to cancel, right? So we would look at this and say, well, how come this doesn't cancel? Maybe our answer is not right. Or maybe there's something we could actually do with that top part. Well, if we took out a -1, right, out of this whole thing as a greatest common factor, not something we would normally do, but it would work in this case. -1 taken out would leave us with a positive x and a positive 6 all over x minus 7 and x plus 6. And you can see that the x plus 6 parts would cancel, and that leaves you with a -1 on the top and an x minus 7 on the bottom. This answer is D.